In this video, we're going to go over what was included in the kits. You may have received slightly different parts, and that's okay. Just let us know if you have any questions. The first part we're going to go over is the breadboard. This allows us to form electrical connections and create circuits without permanently defining what those electrical connections are. We can easily add components, remove components, add wires, and so on. Before moving on to a final circuit. Once we move on to a final circuit, we create what's known as a printed circuit board, or a PCB. And a PCB essentially has those connections, very well-defined connections that can't be changed. With the breadboard, we can change them very easily. This is a top view of a breadboard. First, we're going to look at the middle portion. In the middle portion, the rows are connected to each other. So in row 30, columns A through E are connected to each other, and the pins in columns F through J are connected to each other. So you'll see that those connections, the pins that are connected to each other, are in the rectangles. And we should be mindful that the pins in columns A through E are not connected to the ones in columns F through J. So that's kind of shown in these rectangles. They're separate rectangles. Yeah. And this is true for this middle portion between the lines on the left and the right, for all of these rows in the middle. Next, we look at the left and right of this breadboard, the left and right portions of this breadboard. We'll find that the columns are connected to each other. So in this plus column, all the pins in the rectangle are connected to each other. And the same is true for the minus column. That being said, the pins in the plus column on the left and the pins in the plus column on the right are not connected to each other. So it's only within these individual columns that the pins are connected to each other. You may have received jumper wires or similar wires. These are used to connect components on the breadboard. So for instance, if I want to connect, I could connect, for instance, something on row 20 to something on row 30 by adding a wire between those rows. And of course, you can add wires from the middle portion to the columns, or to an external device, and so on. Next, we're going to look at the feather. This is sort of the brains of our circuits, and it can both read sensor inputs, it can provide outputs to other devices to control them, and so on. Be careful and don't connect the ground pins with the 3.3 volt voltage input or 5 volt pins. This will cause what's known as a short, and that could destroy the device. We have a breadboard here. It's very similar to the one that was in the image, except there's only a column on your right. I've actually removed one of the columns, but that's okay. And I'm going to show you that you could easily plug in a device. In this case, I have a microcontroller board known as a teensy, similar function, slightly different configuration. And I have these header pins that are attached to the teensy. Sometimes these come already attached to the devices. Other times we have to add them ourselves with a process known as soldering. And the way soldering works is we use a hot soldering iron to essentially create these electrical connections by adding a piece of metal to the pins. We're not going to discuss this in too much detail because we can't really do soldering virtually for this onboarding, but just wanted to mention it in case you're interested. So once these header pins have been soldered, we can easily take this breadboard and attach it onto it. Now, what you'll notice is that an ideal way to do this is to place each of the header pins or each column of the header pin. So this has a left and a right column, for instance. We can place those header pins on opposite sides of this middle divider. That way, the pins on the left and the pins on the right aren't connected to each other, but we're also taking advantage of this sort of empty space that's in the middle. So you'll see that these header pins attach very nicely into the breadboard. And you'll see that, as I've described, it's on the two different sides of this middle divider. That way we can connect something to this column of pins on this side and to this column of pins on this side, without the pins on the right and the pins on the left connecting to each other. Now, one thing I can do is add a wire, and add a wire to one of the rows. You'll see that wire, that white wire. And now this, whatever is connected to this end of the wire is going to be electrically connected to this pin of the microcontroller device on the bottom left. So as you can imagine, this is very convenient, and the other end of the wire can either go to an external device or it can connect to a different row on this breadboard. We'll see more of this later. You also received a battery. This plugs into the battery connector of the Feather. And by the way, you can verify everything I'm saying by going to this Adafruit link and reading up on how it's powered and how this attaches to the battery. The reason I pull up this link is because we want you to be familiar with how to look up information that you'll need. So for instance, on another project, you might be working with a board like the TNC that I showed you, and the exact configuration might not hold. So you should get in the habit of actually looking up this information and verifying that what I'm saying is indeed true. That being said, you might actually not need the battery because a lot of times the micro USB cable that connects to on this left part of the board that connects to your computer is provides sufficient power to the board. Next, we're going to take a look at LEDs, or light emitting diodes. What a diode is, in general, diodes only allow current to flow in one direction. With LEDs, light emitting diodes, they are special because they emit light. On the left, you'll see what an LED looks like. You may have received something that looks like this. And on the right is the diagram that we would use in a circuit. Note the difference between a normal or any diode and a light emitting diode with the arrows that show that light is being emitted. Also, be careful with the direction that you wire LEDs, because if they're wired in the wrong direction, and since they're diodes, current can only flow in one direction. If they're wired in the wrong direction, current cannot flow through the LED and it won't turn on. So that's something to be aware of. Resistors, this allows us to control voltage and current and so on. On the left is what a resistor would look like, and on the right is a circuit symbol, what we would use in a schematic diagram. Next, we have capacitors. These have various applications, including to store charge and in various filtering applications. We're not really going to be working with these, but I believe they were sent to you. On the right is the sort of diagram we would use in a circuit drawing or in a schematic. And on the left is what a capacitor would look like. There are other capacitors that look a bit different than the ones shown. There's two types of capacitors. There's non-polarized and polarized. In the non-polarized case, direction doesn't matter, whereas with the polarized case, the direction of the capacitor does matter, sort of like the LEDs that we discussed. We also have a GPS unit, a micro SD card, and an SD adapter. Not everyone is going to receive an SD adapter, an SD card reader. Most people will receive SD card readers. Some will receive micro SD card readers. The difference is simply to whether to add this adapter or not. A BMP388, this controls this provides us with readings of temperature and pressure, and I believe we can also calculate altitude from the pressure reading. We're now going to look at N-channel MOSFETs, and these sort of act as switches. Essentially, the voltage at the gate controls whether the drain and the source are connected to each other. In terms of where I took this image from, you can actually Google the part number of the MOSFET that we sent you, and you might find a page that looks like this. This is from an electronic supplier, DigiKey, which we often purchase parts from, and you'll find that there's a link to a datasheet. So go ahead and click on that. And you'll find that on the datasheet, you'll see this image that is exactly identical to the image that was on my slide. Some of you may have received a slightly different N-channel MOSFET, in which case the wiring might be different. So this pin configuration might not hold. In that case, I'll be using this in future examples and demos. So make sure that if you have a different model, you look up the datasheet and try to figure out what pin corresponds to what the source, gate, and the drain. So that's something to be aware of. And in general, you want to double check everything that I tell you, just so you get into the habit of doing that and referring to data sheets. On the next slide, I have the diagrams of MOSFETs that we would put on like a circuit diagram. On the left is an N-channel MOSFET, which we just discussed. On the right is a P-channel MOSFET. With they both act as sort of switches, and the gate voltage in both cases control whether the drain and the source are connected to each other. The differences are that, first of all, in the P-channel MOSFET, the source is connected to a positive voltage generally, and the drain is connected to our device or our load. And in the N-channel MOSFET, the drain is connected to, again, our load, whereas the source is generally connected to 0 volts or ground. Another difference is that, at least with the enhancement type N-channel MOSFET, and we'll get into the types in the next slide, with the enhancement type N-channel MOSFET, if the gate voltage is high, then the drain and the source are connected to each other. If the gate voltage is low, then the drain and the source are not connected to each other. With the P-channel MOSFET, it's the opposite. So if the gate voltage is high, then the source and the drain are not connected. And when the gate voltage is low, the source and the drain are connected. So that's something to keep in mind. In terms of the different types of N-channel MOSFETs, I believe these types also exist for P-channel MOSFETs, but we won't get into how that exactly works. And we're just going to focus on N-channel MOSFETs. With enhancement type N-channel MOSFETs, when the gate voltage is high, the drain and the source are connected. And when the gate voltage is low, the drain and the source are not connected. With the depletion type N-channel MOSFET, the opposite is true. So the gate voltage is high when the gate voltage is high, the drain and the source are not connected in the depletion case. And when the gate voltage is low, the drain and the source are connected in the depletion case. For this particular MOSFET that we sent you, you can actually look at the data sheet and you'll see that it describes the MOSFET as an enhancement mode transistor. Enhancement, you're generally going to be working with enhancement mode MOSFETs. Next, we have a radio module that works with the feather, a strain gauge, and this measures strain, force, and so on. An inertial measurement unit, or IMU, which also serves as an accelerometer, gyroscope, or magnetometer. I should say and magnetometer, because it does all of these functions. You may have received one or two of these. They both perform similar functions. An anemometer, and this measures wind speed. And nichrome wire. And generally, nichrome wire is used, we run a current through nichrome wire, and that heats up the wire, and this can be used to cut certain materials. That's the end of this video.